AC motor is a motor that converts alternating current into mechanical power by an electromagnetic induction. This motor is driven by an alternating current. The rotors and the stator are the two important parts of this motor. The rotor is the rotating part, while the stator is the stationary part. This motor may be driven by single phase or three-phase. Three-phase AC motor are widely applied in industry such as the factory, as it can provide a bulk energy conversion from electrical to mechanical. For small power conversion, single-phase AC motor is used. As it is small, it can provide a variety of service such as at home and office. Some of the domestic appliances that used single-phase AC motor are like refrigerators, fans, and also washing machine. So there are two types of AC motor. The first one is the synchronous motor, and the second one is the induction motor. So let's see on how it works. In this video, we will learn the working of a three-phase squirrel cage induction motor. It has two main parts, stator and rotor. Stator is the stationary part and rotor is the rotating part. Stator is made by stacking thin slotted highly permeable steel lamination inside the steel or cast iron frame. Winding wire passes through the stators. When three-phase AC current passes through it, something very interesting happens. It produces rotating magnetic fields. Here, three-phase AC current passes through stator winding, produces a rotating magnetic field. So, current will be induced in bars of the squirrel cage, which is shortened by end rings, and it will start rotating. That's why it is called an induction motor. Electricity is inducted in the rotor by magnetic induction rather than direct electric connection. Rotor of synchronous motor produce constant magnetic field, and stator produce revolving magnetic field. The field coil stator excited by three-phase AC supply. This will produce revolving magnetic field which rotate at synchronous speed. Rotors are excited by DC power supply, so it acts as permanent magnets. Alternatively, rotors can also be made of permanent magnet. The reaction of rotors and the RMF is interesting. Assume you are giving an initial rotation to the rotor with the same direction of RMF. You can see the opposite pole of RMF and rotor will attract each other and lock magnetically. This means that rotor will rotate the same speed of RMF, or rotor will rotate at synchronous speed. An AC drive is usually used to control the speed of an electrical motor. So, the speed of the motor can be controlled by changing the frequency of the electrical supply. So I think that's all for AC motor.
So I'm going to talk about brushless DC motors. What are brushless DC motors? Okay, brushless DC motors are DC motors that use magnets instead of brushes and a commutator for commutation. The benefit to that is that they don't suffer from brush wear, but the drawback is they need electronic current phase for commutation. Furthermore, motors called brushless DC motors have permanent magnet. So technically, they are permanent magnets synchronous motor run on AC. The biggest distinction between brushless DC motor is whether or not it is sensored or sensorless. A few types of brushless DC motor are gimbal brushless DC motor, single pole DC motor, and outrunner DC motor. The numerous focal points that brushless DC motor have make it a popular component in a lot of distinctive applications. Some of the applications that use brushless DC motor include consumer electronics, transport, heating and ventilation, industrial engineering, and model engineering. Alright, so let's enjoy the video on how brushless DC motor works and its control.
This video shows how brushless DC motor works. Electromagnets change polarity due to integrated inverter. Electronics control the waveform. DC signal is converted to AC. The changing polarity causes the rotor with permanent magnets to spin. The figure shows a typical arrangement for driving a brushless DC motor with Hall effect sensors. The output from the microcontroller derived by the IGBT driver comprises pulse width modulated PWM signals that determine the average voltage and average current to the coil. The motor uses 3 Hall effect sensors A, B, and C to indicate the rotor position. The rotor itself uses 2 pairs of permanent magnets to generate the magnetic flux. The system employs a 6-step commutation sequence for each electrical revolution. Because the motor has 2 pairs of magnets, 2 electrical revolutions are required to spin the motor once.
So, AC motor or DC motor? So from the name itself, we can know that AC motor are powered by alternating current and DC motor are powered by direct current. So to choose which type of motor to use, we need to identify first what type of circuit we are using. DC motor work best in application that needs the speed of the mechanism to be externally controlled, because in DC motor you just need to regulate the voltage supply rather than AC. Meanwhile, AC motor is best used in application that needs to be used in long time because AC motor is more rugged than DC motor. Talking about the size, with the same capacity, usually DC motor are larger than AC motor. There are actually several factors that affecting this. One of it are the area of winding. The cross-sectional area of conductor is more in DC motor than AC motor, as resistance is inversely proportional to the area. To decrease the resistance of the winding, hence to increase the current carrying capacity of DC motor, need to use more cross-sectional area of conductor. Whereas in AC motor, it is not possible to increase the current carrying capacity to a great extent, like in case of the DC motor just now, because it is due to the skin effect. This is the reason for limit the value of current in AC motor. Thanks to the high startup torque power in DC motor, there are more fitting in applications that need a huge amount of torque in the startup, such as windows in farms. Huge torque is needed to start the windows motion, whereas in AC motor, low torque is used in applications such as the conveyor belt in the factories. Basically, there are no solid judgment on whether DC motor or AC motor is better to use compared to each other. There are actually multiple factors that affecting which type of motor that is needed in each cases, such as the type of startup that we just discussed right now, the load, the torque is produced, electrical power used by the motor, performance such as analyzation of the humidity, the ambient temperature of the surrounding, and variations in the rotational speed. So before you consider in using AC or DC motor, you need to consider multiple factors. Thank you.